Today we will discuss, so in the previous class we have discussed about Hadoop concept, that is HDFS mainly, the file system. So as I told you in the previous classes that Hadoop is made up of two components, one is HDFS, another is MapReduce. Okay, HDFS is for storage and MapReduce is for processing. Okay. And the difference between the traditional file systems and HDFS is HDFS, it is a distributed file system. It's a distributed file system. That is, a single instance of HDFS can work on multiple machines. Okay, a single instance of HDFS can work on multiple machines. That is a cluster of machines. And second is it is highly fault tolerant to data loss. It is highly fault tolerant to data loss, with by implementing replication. It is important data loss with replication. Okay, this we have discussed yesterday. Okay, and today we shall see what are the various components that are present in big data environment, and what are their roles, and what are their importance. Okay, where do they come, where do they use, where we use those components. Okay, see this. First, let me list out all the components that are in the big data environment. Then later, I will tell you the purpose of each and every component, where they are used, and what is their purpose. Okay, the first one, uh, HDFS, that is MapReduce. These two are part of Hadoop. And next, we have Hive, Pig, next Scoop, SQOOP, Scoop. Okay, and Flume, Kafka, and we have Hbase, Cassandra. There are many other, but they are the mainly used. And finally, Spark, SPRK, Spark. Okay. Among these, only HDFS, it is the storage component. It is the purely storage component, storage of data, storage of big data. And MapReduce, Hive, and Pig, and Spark. These four components, MapReduce, Hive, Pig, and Spark, all these are processing components. What do we do with these components is, the purpose of these components is to do the processing of data. Processing. Even Spark also we go with processing of data. Once the data enters into HDFS, the data can be processed by either MapReduce, either by using Hive queries, either by using Pig scripts, and by using Spark. So by using MapReduce, we need to create MapReduce application or MapReduce program. Actually, it is called as MapReduce application. So we use a language called as Java here. And in Hive, we use queries. Okay, and that must be written in the form of a script. In the form of generally we use write by using shell scripting. All the queries must be written in a shell script. Okay, and the language we use here is HQL, High Query Language, and Pig. Here we call them as scripts, Pig scripts, and the language used is Pig Latin. Is okay. Okay. And coming to Spark, Spark also uses a language. Spark also uses the programming. We need to create like MapReduce, like for MapReduce, we need to create a program for Spark, and that program can be implemented by either Java language or Scala language, Python or Java. So Spark also programs can also written by using Java, Python, Scala or R language. Okay. So HDFS is for storage purpose. MapReduce. Second. Okay, so HDFS is for storage purpose. MapReduce, Hive, Pig, and Spark. These are the components that are used for processing of the data that is stored in big data environment. Okay, Hadoop, that is mainly in HDFS. Okay, now let me talk about Scoop, Flume, Kafka, Hbase, and Cassandra. Okay, Scoop, the first component is Scoop. Okay, actually, let me draw a figure of this big data cluster. Let us assume this as an Hadoop cluster. This as a Hadoop cluster made up of certain number of machines, certain number of nodes in the cluster. Just let us assume. Okay, now so the data has to come from external world into Hadoop environment. That is, Hadoop is made up of what? HDFS and MapReduce. Both are internally installed in all these machines. Okay, now the data has to come from external sources. So what could be those sources? What are the different sources that can Hadoop, no, we can move the data into Hadoop environment, and in which mode, in which fashion we can move the data from external sources into Hadoop environment. That is HDFS for storage purpose. Only when the data is stored in HDFS, then only we can start processing it. Why? Because HDFS is the fault tolerant file system and distributed file system, so that we can process the data in distributed mode. Okay, remember. So HDFS is distributed, and similarly this MapReduce or Hive or Pig or Spark, whatever the processing components we have, just now I told you, these are distributed computing processing machines or frameworks. Okay, distributed computing or distributed processing frameworks. It is distributed storage, and these are distributed processing frameworks. Okay, so to process the data in big data environment, the data has to enter into this HDFS. Okay, so in order to enter the data and move the data in HDFS, what are the tools that we use, in what are the different modes in which the data can enter into this HDFS? Okay, mainly two types of modes. In two modes, we can move the data into HDFS, mainly in two modes. One is batch mode. One is batch mode, and second is stream mode. Stream, stream mode. We can move the data from external sources into Hadoop environment in batch mode and in stream mode. I think you can know what is batch mode and what is stream mode. Batch mode is something like let's come to scope later. Batch mode is something like there is some data in the server, external server. The data is already stored in the server. Okay, that is already stored. That is some previous data, some historical data. We say that some historical data that is already stored in those external machines, external servers, and that already stored data we are moving into HDFS. If we try to move already stored data, already existing data in some servers, external servers, into Hadoop environment, that too into HDFS, that can be called as batch data. Batch data in the sense the data that was collected, okay, that was collected some period ago. Before some time, that before some period, the data has been collected. The data that was already there in some servers, external servers. If we're trying to move the data into HDFS, that type of data we call as batch data, and the type of movement of data is called as batch data transfer into HDFS. Okay, and one more type of transfer of data is stream data. I told you, streams is something like the data will flow continuously. The data will flow continuously. Just let me tell you the difference between this. Let us say batch data. Batch, coming to batch data, I told you that the data must be already present in some external server. So let us say the size of the data is some 5 TB. Let us say the data in this server is 5 TB. So we start the moving of data from the server into HDFS. Those 5 TB of data will start moving into HDFS. Till when 5 TB of data completes, the transfer also gets completes. That is, certain amount of time will take for transfer of this 5 TB, and when the transfer gets completed, the transfer is over. That's it. The transfer of data is over. That is batch. That is called as batch data movement. And coming to stream data. Stream, the general meaning of stream is something which is flowing continuously. We call river stream. River as a stream. That is, the in river is something like where the water flows continuously. That water doesn't stop sometime and doesn't wait for some time. Okay, the water flows continuously. So continuous flow of something can be called as a stream. So here also, if the data is flowing continuously until we stop, unless we stop, there is no ending or there is no starting for the data. Okay, the data will be flowing continuously. Once we start entering, if we ask if we do something to move the data into HDFS, the data will start entering into HDFS and it will flow continuously unless we stop. That is, there is no end to the data. Why? Because it is stream data. So there are two types of modes of entering the moving data into HDFS. One is as a batch, one is as a stream. So there are certain applications in our industry or in our life, that is two types of servers are two types of sources. Some sources write the data in batch mode and some sources write the data into HDFS in stream mode. That is, mainly when we go with when it comes to stream data, when we go with certain social media sites like social media websites like Facebook, some WhatsApp, some Instagram, and YouTube, and some so there are certain websites or certain applications are there in our real life which generate the data continuously. Okay, which generate the data continuously. So the data that is coming, that has to be processed continuously. Okay, and the data will not stop at certain point. Data will not stop in the will not start in the morning and will not stop in the evening. No, that won't be there. The data will flow continuously. If you want to move the data flowing continuously into HDFS, we can move the data also. Okay, change this करो मला process करा change this करो. Okay, if there are certain applications which can generate the data continuously, so like social medias, okay, like social medias and online shopping carts, online shopping websites, okay, like Amazon, Flipkart, and Alibaba. Some all such shopping websites also they generate data continuously, in the sense they operate 24 by 7, 24 by 7, and their nature is to generate the data continuously, like cell phone towers, cell towers. Okay, the data gets generated continuously. So for all such type of sources, the data will be generated continuously, and we can move the such type of data also into HDFS environment. And in addition to that, we can also move batch data. If I have some data stored with me, then later I want to process it, you can do that. And the data is getting generated with me continuously. I want to move the data into HDFS continuously as a stream. That also we can do. Okay, now coming to this batch data, coming to this batch and coming to this stream. Okay, coming to this is now for the stream, in order to move the data in a streaming fashion, in a stream mode into HDFS, we use certain components. Certain components are used to move the data into HDFS in a stream fashion, to move the data continuously, collecting from external source, collecting data continuously and moving it into HDFS in a continuous manner. Okay, the components like Flume, Kafka, and there is one component called as Strum. Okay, like the certain, these are called as streaming components. These components are used to move the data, to stream the data from external sources into HDFS environment, into HDFS or Hadoop environment. Okay, Flume, Kafka, and Strum. These are the, some other components are also there, but these are the, proper the, mm, largely used components for streaming purpose. So for external, from external sources which are generating data continuously, from these sources, if we want to move the data in a streaming fashion into HDFS, we can do by using these components, Flume, Kafka, and Strum. Some other components are also there. That's not that much required, but these are mostly used here. Okay, and next, coming to batch mode. Okay, if you want to move the data into Hadoop environment in batch mode, what are the components we can use? Okay, we can use, the first component is, if the data is RDBMS, if the source is RDBMS like MySQL or Oracle, some any RDBMS, if there is any, if the external source is any RDBMS, if we want to move the data into HDFS in batch mode, we can use a component called as SQOOP, scoop. Okay, this is the name actually derived with two terms, that is SQL plus Hadoop. Okay, so they have merged these two words and formed a new word called a scoop, SQOOP, scoop. So the purpose of scoop is to move the data from any external RDBMS server into HDFS environment. Not only from RDBMS, now the latest version of scoop can also read the data from mainframes, into into HDFS, that is Hadoop environment. Okay, so scoop is the component that can be used to move the data into Hadoop environment, that is into HDFS, from RDBMS servers as well as from mainframe servers. Remember this point. Okay, now let me there's one more point, that is, if it is RDBMS, okay, if it is mainframes, okay, and if the servers are generating data continuously, we can use these components. Then what about some servers that are not RDBMS, that are not generating the data continuously? Some servers where the data is there in batch mode only, the data is in batch mode only, but they are not RDBMS. In such case, how do we move the data into HDFS? How can we move the data into HDFS? In that case, we can use inbuilt functionality of Hadoop HDFS, that is called as distcp. It is called as distributed copy. This is called as distributed copy. Remember this. So we can also move from external sources other than RDBMS or some other external servers into HDFS in batch mode. Okay, by using the internal functionality of HDFS, which is called as distcp. Distcp is called as distributed copy. In a distributed mode, copy the data into HDFS. This is the meaning of this distcp. So these are the different ways of moving the data into HDFS. Batch mode, mainly we can divide them into two modes. One is batch mode, another is stream mode. Okay. So once the data enters into HDFS, we can process the data by using now let us say by using any of these components, the data has entered into HDFS. So into the data is moved, the data is stored into the machines, the nodes. Now what we can do here, we can do the processing of, we have to do the processing of this data. How do we process this data? That processing can be done by using the components that I told you just now, by using either MapReduce or by using Hive or by using Pig or by using Spark. Okay, we can process the data by using any of these components. MapReduce can process structured, semi-structured as well as unstructured data. So generally from here, when we move the data from RDBMS, the data will be purely structured. Okay, RDBMS maintains the data in structured form, so the data will come in structured form only. And from external servers in stream mode, and from these servers, the data may be structured or semi-structured or unstructured. So the type of data entering into HDFS may be structured, semi-structured or unstructured. Three different varieties of data can be there. So which component to use for processing the data, that depends upon the data that we are using for processing. Okay, if we're trying to process structure, let us say we have moved RDBMS data into HDFS by using this component scoop. Okay, so it is structured data. So what is the component that we use to process this structured data? The data has to be processed in a distributed fashion. In a distributed mode, the data has to be computed or processed. So the solution is we can go with Hive. Hive is efficient in processing structured data. And one more component that is called as Spark SQL. In Spark, we have another component called as Spark SQL. So these are the two components that are mainly intended for processing of structured and semi-structured data. Structured and semi-structured data. Okay, so these are two components that are mainly meant for processing of structured and semi-structured data in distributed mode. Okay, all these components process the data in a distributed fashion. Okay, and if the data is unstructured, what could be the components we can use for them for the processing of unstructured data? The components can be either MapReduce, or it can be pig, it can be MapReduce, it can be pig, and one more that is called as Spark Core. Okay, there's a component called as Spark Core under Spark only. Okay, so these are the components that are preferred to handle unstructured data. That doesn't mean that these components cannot process structured and unstructured, semi-structured. They can process, but the thing is, they are very good at processing unstructured data. But for structured and semi-structured, we can go with Hive and Spark SQL. Okay. Okay, this is a brief overview of the components that are used for moving the data from external world into Hadoop environment, that is into HDFS. And once the data is loaded into HDFS, we can use these components for processing of the data in a distributed fashion. Structured, semi-structured, we can go with Hive and Spark SQL. And for unstructured, we can go with MapReduce or Pig or Spark Core components. Okay. Now, next, coming to some other components, we have two other components. They are called as Hbase and Cassandra, and we have also one more component that is called as MongoDB. Okay, so we call these components as NoSQL databases. Okay, database, and we have NoSQL databases, and already we have the knowledge of RDBMS. What is an RDBMS? Relational databases. These are called as relational databases, like Oracle, MySQL, some Derby, some uh, RDBMS are there. So what is the difference between these two? Oracle, MySQL, Derby, these are the RDBMS and NoSQL. The thing is, when we go with this Hadoop, what type of processing we can do? We can process the data, but what type of processing we can do? Okay, we can process batch data that we have just discussed. We can in batch mode we can process the data. In batch mode we can process the data, and in stream mode also we can process the data. Stream mode we can process the data. Don't get confused with this batch mode, stream mode, with this batch and stream modes. These are different. These are the ways in which the data enters into HDFS. Once the data enters into HDFS, in what mode you are trying to process the data? In batch mode or in stream mode? So batch mode in the sense, after the data enters into HDFS, you know, as soon as the data enters into HDFS, if you're processing the data, immediately, the data is entering into HDFS and you're processing immediately. Okay, this type of processing can be called as stream processing or live processing. Stream processing or live processing of data. As soon as the data enters into HDFS, processing it, that is called as stream processing. But one more case will be there, that is, the data is entering into HDFS, the data has entered into HDFS totally. Okay, so after some time, we are not processing the data immediately. After some time, after some period, maybe 1 day or 1 hour, or it can be 1 week or 1 month, what it may be. Okay, so after some duration of time, if you are going with processing of data, then that can be called as batch processing or batch mode processing. And if we try to process the data in HDFS immediately once the data enters into HDFS, that type of processing can be called as stream processing, batch processing and stream processing. So in this, among these components, Hive, Spark SQL, MR, Pig and Spark Core, some components are very good at batch mode processing and some components are very good at stream mode processing. Okay. So MapReduce is mainly preferred. MapReduce is mainly preferred for batch mode processing, and Spark is preferred for stream mode processing. Remember this. So for batch mode processing, MapReduce preferred, and for stream mode processing, Spark is preferred. MapReduce or Hive or what you call as Pig. These are preferred for batch mode processing of data, and for stream mode processing of data, Spark is preferred. Spark Core, Spark SQL, all the components of Spark, whether it is Core, SQL or any other component, the entire Spark is very good at stream mode processing. It is good at batch mode as well as stream mode, Spark. But MapReduce is not good at stream mode processing. It is very good at batch mode processing. So that is why the industry is moving towards running. The industry is running behind Spark, but not MapReduce or Hive or Pig. Why? Because the Spark is very good at batch mode as well as stream mode. But whereas MapReduce or Pig, they are good at batch mode only, but not at the stream mode processing. Okay, understand here. Moving of data into HDFS, batch mode, stream mode, and once the data enters into HDFS, the processing can be done again in two modes, batch mode and stream mode. Okay, to move the data into batch mode into HDFS, we can use scoop if it is structured data, that is from RDBMS or mainframes. If it is from other servers other than RDBMS or mainframe servers, we can use dist-cp, internal functionality of HDFS. And if the external sources in which the data is getting generated continuously, we can use these components. And for processing, we can use these components. Okay, next. Coming to this. NoSQL databases and RDBMS. What is the difference between these two types of databases? Okay, Hbase, Cassandra, MongoDB. Okay, in these are the databases. These are the databases. These are used for storage of data, and these are also used for storage of data. So in RDBMS, the data is stored in structured form. The data is in structured form. Here also the data will be in structured form. Okay, the data is stored in structured form. Here the data is stored in the form of rows. The data is stored in the form of rows. Row, one row, second row, third row, fourth row. A table is made up of like this, made up of rows and columns. Okay, rows and columns. The data is stored in the form of rows and columns in case of this RDBMS. Okay, now Hbase, Cassandra on this MongoDB. The data is not stored, the data is in structured form only. The data here it is structured form, here also the data is structured form. But the way of storage, the way of storage of data is different. Here the way of storage of data is in the form of rows, and here the way of storage of data is in the form of columns. The form of columns. Okay, these we call as actually column oriented databases. Column oriented databases. And these are called as row oriented databases. Row oriented databases. Okay, the difference is, this is the only the difference between this, okay, column oriented and row oriented. What is that? Okay, what is the difference between row oriented databases and column oriented databases? Okay, first the point is, both the database, the data is stored in the form of structured only. Okay, and here column oriented, row oriented. Let me tell you what is the difference between row oriented databases and column oriented databases. In what way these two are different? And remember here, NoSQL stands for not only SQL. These are SQL databases. These are SQL databases, and this is NoSQL. NoSQL in the sense not only SQL databases. Okay. Next. Now let me tell you the difference between row-oriented and column-oriented databases. This is very, very important. Okay. Now see this. The data is stored in the form of rows. Let us consider a table. Let us take some sample rows. Sample rows. So obviously it will also have some certain number of columns, rows and columns like this. First record, second record. Okay, each record of a person or whatever it may be. Okay, if it is a banking database, the record of each person. Okay, there are different types of tables, there are different types of tables. The data stored in a table differs. Okay, that depends upon the data that we are storing in. Let us say if it is some customer table, let us say the customer table, each row represents the data of customer. Okay, every row represents the data of a customer. So entire row, this is the information of one customer, or the record or data of one customer. Likewise, each row represents one record. Remember here, each row represents one record. Now, how many columns are there here? Let us assume here 1, 2, 3, 4, 5, 6. Let us say we have 6 columns. 6 columns. Okay, 1, 2, 3, 4, 5, 6. So every record is having how many columns here? 6 columns. Okay, so even though, let us say customer name, customer ID, customer some contact number, customer address, and customer's first address and second address, let us say address 1, address 2. Okay, and finally let us say some email, optional. Let us say email is optional, and address 2 is also optional, let us say. Okay, optional, and these two are optionals. And among these 6 columns, 4 columns are mandatory and 2 columns are optional. Let us assume like this. So that every customer compulsory should have 4 columns values compulsory and 2 columns are optional. But see here, even though the data is optional here, compulsory the customer need to allocate according to row databases. The data has to be, the memory has to be allocated to these 2 records also. We cannot skip. We cannot make the first customer, even though first customer is not providing address to and email details, we cannot confine the amount of memory allocated to the first customer record to only 4 columns. We cannot do this. We have to create 6 columns for this customer. Whether the data is present or not, we have to provide 6 columns, and the memory will be allocated for 6 columns. the memory is going to be wasted. Okay, and this is the first point. Okay, this can be the case with many other customers, not only with this customer, many other customers. That is, whether that column is important to this customer or not, whether that column data is present for this customer or not, that doesn't matter. For every customer, each and every column must be there. That's it. Okay, and that is, every record, the first point is, every record should have same number of columns, same number of fields. We can say should have same number of fields. That is nothing but columns. Same number of fields or columns. This is the first point. And the second point is, this is the first point. Second point is, let us say name, ID, contact number, address one. In this one, suppose if I write a query, select contact number, select the contact number from, let us say, some table 1, let us say from table 1, where customer ID equal to some ID, we give some ID. Okay, select the contact number from table where customer ID equal to some ID. So where is the ID here? The ID is the third column here. Sorry, contact number is the third column, ID is the second column. Sir, ID must be the first column, actually primary key. So let us give the name here. Okay, now the thing is, we are trying to retrieve contact number here. We are trying to get the contact number of the customer. Okay, so this contact number is the third column, it is in the third position. Okay, so internally the data is stored in the form of a row. That is, when we give this condition, so when we specify this query, what will happen internally is that query has to trace the record like this. First it will look for this name and ID, and after that contact number. Okay, let me tell you, let me be very clear with this now. When we create name here, let us say name, the first name, let us say we have allocated 20 characters for storing name, and ID, let us say we have created some 10 characters for storing ID, and after that we get contact number. Okay, so internally when we supply this query, what this query has to do is, internally how the parsing will be done is, it will look for the data after 30 characters. It will look for the data after 30 characters, and it will fetch that record, fetch the data, and it will throw as the result. Okay, it will fetch the data and it will throw the data into throw that as a result. That is, if let us say, if there is some data in the sixth field, what has to happen when we are trying to retrieve the sixth field? In that case, it has to pass through all these fields, and finally when it reaches this position, it will retrieve that record. That is, after passing first record, second record, third, fourth, fifth, after passing all the records, it has to fetch the sixth record and has to give the result. Okay, if it is very first record, no problem, in the very first attempt it will throw us. If it is first record, it has to pass through first record, first value, it has to get the second value. If it is sixth value, it has to pass through all the 5 values, it has to get the fifth value. So likewise, if there are 100 columns are there, let us assume. So if we give any query to get the 99th value, so the query has to pass through all the 98 values, and it has to get the 99 value and throw the result. So unnecessarily the time is getting wasted here. Okay, if the number of columns increase, the time taken for retrieving the data also increases. Okay, so, and one more thing is, some data may be optional, some data may not be there for some fields, for some customers, from some records. Even though the data is not there, those columns must be empty, and memory also must be allotted to those columns. So these are the problems we have with these row oriented databases. Okay, so how we can minimize the effort? The challenges here are, what are the challenges here? The first challenge is Even though, so here, let us assume the first customer is not having two fields. The two fields are empty. So we must be in a position, what the solution has to give, this is the problem we have here. The solution has to provide that customer 4 has to be allocated memory only for the records, only for the values that he has. So here the first customer is having the values only for the first four columns. So only for the first four columns only the memory has to be allocated. Okay, that is the first challenge. That is, the memory must be allocated. Memory must be allocated to only the available data, to only the available values or available data. Available data. That's it. Okay, the memory must be allotted to only the available data. Non-available data memory should not be allocated. It must be just deleted. That's it. It must not be created. Deleted is the later one. That is, the memory should not be allocated for non-available data. Memory should be allocated only for available data. And second point is when I request for uh, any field here, it should not pass through all the fields. Directly it has to get the data of this. The query directly should contact the sixth field and it has to get the data. That's it. It should not pass through all the fields. Directly it has to get the data. This is called as a random read. This type of reading is called as what? Sequential reading. Sequential access or sequential read. So this type of reading of data, passing through one, all the fields, passing through field by field, this type of reading the data is called a sequential access or sequential read. I do not want this sequential read, sequential access. With sequential access, the time is going to be wasted. As the number of columns, number of fields increase, the time will get wasted. So in order to save the time, I should be able to read the data in a random mode. Random mode in the sense, I require third field. Directly the query has to hit the third record, it has to get the third record, that's it. It should not pass through first field, second field, like that. If I need 99th record, directly the query has to hit the 99th record, 99th value, it has to get me the 99th field value, that's it. That is called as random access. That random access is possible here. Okay, that random access is possible. So these are the two challenges. For this, the solution is provided with this NoSQL databases. That is not only SQL databases. How this is possible? How this NoSQL databases have made possible is by storing the data in columnar format. By storing the data in columnar format. So here the data is stored in form of rows, row by row. This is the first row, second row, third row, fourth row, like this. Okay, now the data is stored in NoSQL in columnar, not row format, columnar format. Okay, now in the next slide I will tell you how columnar data will be stored. Let me tell you. Okay, let us assume this is RDBMS. This is some RDBMS. Let me take only two rows. For instance, let me take only two rows with certain number of columns. Row 1 and row 2. Column 1, column 2, column 3, column 4, column 5 and column 6. Total 6 columns. Okay. Some values are there. This is called as row oriented storage of data. Let me show you how column oriented, how the data will be stored in columnar format. Okay, now row 1, C1 data. Okay, next row 1, C2 and its data. So this is the data. Okay, this is the data and this is the data. I am writing D here to specify the data here. Okay, D. Okay, now row 1 again C3 data. Next to row 1 C4 data. Row 1 C5 data. Row 1 C6 data. This is one complete record of column oriented database. Okay, see this row is getting converted into what? A column. Can you see this? Columns. Okay, the columns, what are the columns we have here? 1 2 3 4 5 6. The columns are in sequential manner here. Now it is one after the another. Okay, it is stored in this fashion, in this mode, the column data. And now the data is stored in this fashion, top to bottom. It is from left to right. Now it is stored in top to bottom. Okay, so when we hit some, similarly for row 2 c1 data, row 2 c2 data. Likewise, all the records will be stored for row 2 also. So this is one record, one row, or one record in the row oriented databases, and this is the way how the data gets stored in column oriented databases. Okay, now in this case, suppose if the first row is not having these two fields, so this data will not be stored, these rows will not be there at all, this will be deleted. Okay, why? Because the data is not there. This row, this record will have only 4 rows like this. Here these are the columns. Now these are stored as the rows. Columns are stored as the rows. Columns are stored as the rows. That is the purpose we call, that is the reason why we call this storage as columnar oriented storage of data. Okay, so if some of the data, some of the columns rows is missing, we delete those rows. So deleting of rows doesn't make any problem, doesn't create any problem. So if you are adding some new data, we can add new row. If you're adding some new column, some value, we can delete that value, delete that row. So generally we don't delete columns, we delete rows. Here also we cannot delete columns, we can delete only rows. So the same concept is used here, deletion of rows, but the data is stored in this manner. So it is very easy now to add some data and delete some data for every record without wastage of memory. Without wastage of memory. Okay, now you may ask, row 1, the data is stored in sequential fashion. Here the data is not stored in sequential fashion. Okay, it is top to bottom, it is left to right, it is top to bottom. And now in this, when the data is stored in this fashion, when we hit some query, to select some C3 data, what is going to do? Directly it is going to attack this, hit this row 1 and C3, it is going to get the data. Okay, so why? Because with the queries will be, the data will be selected in any database based on the row ID. Okay, here the row ID is row 1 and one more ID, internal ID is C3. So with this combination of these two, ID will be prepared here. And in this row oriented database, the ID will be prepared based on primary key. Here the ID is prepared based on the combination of row ID as well as column name. This is called as, in column oriented database we call this as column family, actually column family ID. Okay, this is how, this is the difference between NoSQL data storage and SQL data storage. Okay, not only SQL, this is row oriented storage and this is column oriented storage. Okay, now the thing is, so this is the case with Hbase and Cassandra. Hbase and Cassandra and MongoDB. Okay, columnar oriented databases. These two are columnar databases, and this is different. This is document database, document oriented database. The data is stored in the form of documents here. This is different. Okay, in these two databases, Hbase and Cassandra, the data is stored in the form of columns, whatever we have discussed. So what is the advantage here is, see here, in the previous slide I told you that, HDFS, here we can do batch mode processing and stream mode processing. Now with RDBMS, now see this, can't we do real-time processing of data? real-time processing. Analysis is different and processing is different. Like if we take RDBMS, what do we do? Transactions we do here. Transactions. That is daily transactions like a web bank transaction. It may be a some payment transaction. Some transactions we do, right? So to perform the transactional operations also, to perform the transactional operations, that is whatever we use SQL databases, that is RDBMS, the purpose that we use SQL databases for the same purpose we can use Hadoop environment also for that. Okay, we can use Hadoop environment also. We can use Hadoop not only for batch processing but also for real-time processing, real-time transaction processing, not for just real-time stream processing, real-time transaction processing. So I can tell you now here, that is totally now we can say, we can conclude here with this is, so with Hadoop, and what we can do is we can do batch data processing and stream data processing and real-time transaction processing, real-time transaction processing. Okay, so batch data processing, stream data processing, the data we can use directly HDFS. Okay, and storage we can use HDFS, and processing we can use MapReduce or BigHive and Spark. BigHive, Spark. And for real-time transaction processing, we have to use Hbase or Cassandra. We can use Hbase or Cassandra. These are the NoSQL databases. So what is the difference here is, these are the column-oriented database and these are distributed computing, like HDFS and like MapReduce, all these. HDFS is distributed storage system and these are distributed processing systems. Likewise, when we store the data in HBase or Cassandra, the processing will be done in distributed mode. Okay, so what is the advantage of this distributed processing is we can store any amount of data. We can store any amount of data. That is, we can deal with big data. So what are the traditional servers we have? Traditional databases. Let us take some Teradata, some MySQL, Oracle. These are limited. The cluster size is limited there. Okay, the cluster size is limited to some 128 nodes or 256 nodes. That is, the data size is restricted here. So as the cluster size is restricted, obviously data size is also restricted, but there is no restriction on the data storage when we go with Hbase or Cassandra. Like a Hadoop environment, like Hadoop is highly scalable. Even Hbase and Cassandra are also highly scalable. Whenever we get some new data, if the space is not sufficient, then we can add one more node to the already existing cluster. So likewise, it is highly scalable like that of Hadoop, and these can process any amount of data, that is big data, and in which mode? Distributed mode. And if they can do random transactions. Because of this random transactions only, it will be very faster. Because of the storage of data in columnar format, just now I told you, and because of the distributed nature, it can store any amount of data and it can process any amount. Whatever is the amount of data. If the data size is very huge, if the data size is very huge, it will take some time to process the data. It will take more time to process. The data size increases, the time also increases for retrieving or accessing the data. But in case of Hbase Cassandra, the time can be made, the time of accessing the data can be made as constant. Whatever with the data size, the time for accessing the data will be constant. Why? Because it is going with random access, not with sequential access. It is going with random access, that too in distributed mode. So these are the features in Hbase and Cassandra which make to perform real-time transactions and processing of real-time transactions in a very faster and with any amount of data. That's the advantage we have. The problem with traditional databases RDBMS is, as the data, there's a limit on data. There's a limit on data storage in these servers. There's a limit on the data storage in the servers, and that too, if the data size increases. If the data increases, obviously the time for accessing some data, the time for processing of some data also increases. Why? Because the data is stored in sequential fashion. But in this case, there is no limit on the data storage. Okay, and that as the data size increase, proportionally the time will not increase. The time can be maintained as constant. Whatever the data size, the time can be constant. Why? Because the data is stored in columnar format, which allows for random access of data. Okay, which allows for random access of data. So these are the advantages for going with this NoSQL databases. So in the industry and the people who are using RDBMS nowadays, in future they may go with Hbase or Cassandra. Now most of the industries are there directly they are using Cassandra, but they are not industry is not ready to move to Hbase or Cassandra. Why? Because they have to develop a trust in the people. The people who are using RDBMS, some trust has to be developed in them so that they can move to Hbase Cassandra. It may take some time, but surely after some time, after some data, some years, the data size obviously increase. Okay, even RDBMS cannot, whatever the traditional servers we are using for maintaining RDBMS, they cannot manage the data. So that compulsory they have to go with some of these components only, some of the distributed data storage components only. There, so they are they compulsory they have to go with this, and we have to use. We may use in the future. May not be right 100% now, but in future compulsory we use this for real-time transaction processing. Okay, so this is the brief overview of all the components whatever we have discussed. Okay, let me tell you now. Let me conclude all the components what we have discussed. HDFS, MapReduce, Pig, Hive, Spark, Flume, Kafka, and Scoop, and one more, sorry, Hbase and Cassandra. There are many other, even MongoDB is also, the Mongo is not required actually. So this is for big data storage. Big data storage. And this is for, these four components are for big data processing. Big data processing. These are not for transactional processing. These are not for transactional processing. Oh no, okay. These are for analytical processing. Analytical. These are for analytical processing. Okay. These are not real time. These are not these components. By using these components, we cannot process the data. We cannot do transactional processing. We can do only analytical processing. That analytical processing can be done in both batch mode and stream mode. Batch mode and stream mode. Not real time. Okay, not real time. It can be near real time, but not real time. It can be near real time. Stream mode can go with near real time, but not real time. Remember this. Okay, it is not supported by these components. Next, if you want to go with next, Flume, Kafka. These are the components used to move the data from external sources into HDFS in stream mode. Okay, and Scoop. These are used to move the data from RDBMS, from any RDBMS servers or from any mainframes, from mainframe servers. From these two types of servers, we can move the data from from Scoop into HDFS. Okay, and from Hbase and Cassandra, these are NoSQL databases, and these are used for what? These are used for real-time processing. Real-time transaction processing. Real-time transaction processing. Okay, real time is not real, it is real time. This is near real time. Okay, it's not real time, near real time, and batch mode, near real mode and batch mode. This is real time mode transaction processing. Okay, this is a total overview of these components. Okay, next one, let's give the last concept here. That is Spark. Spark is dominating the processing now. In big data environment, the industry is running behind the Spark, mainly with respect to processing. Okay, see this in the previous slide. MapReduce, Pig, Hive, Spark, and Hbase, Cassandra. All these are used for what? They used for processing of data. Okay, you can see here. These are for batch mode processing and near real-time processing, and these are for real-time processing. Okay, now what is the advantage of this Spark is? Okay, the very advantage of Spark is it is very fast. It is very fast. Okay, it is very fast compared to MapReduce or Hive or Pig, whatever it may be. Hive or Pig, they are it is very fast. Okay, the reason for fastness is there is only one main feature in Spark, that is called as in-memory computation. One of the main features of Spark is it is in-memory computation based model. In-memory computation based model. And MapReduce, Hive, because these are not in-memory computation based models. That is why they are slower for in-processing. But Spark is based on in-memory. We'll discuss when we get into the actual Spark class. We will discuss what is this in-memory computation in very detail of this. Okay. Now the thing is whether we want to go with MapReduce for processing of data or for Spark for processing of data. Which one you have to use? So when we enter into processing of data, we have two choices here. One is, do you want to process the data by using MapReduce and its components, or by using Spark and its components? Tell me here. MapReduce and its components. We can call it as a team, MapReduce team, and there is a Spark team. Okay, so whether you want to go with MapReduce or Spark, that depends. Okay, what are the components in the team of MapReduce? Hive, Pig. These are the These are the components in the team of MapReduce. And what are the components in Spark? These are Spark core. It's simply called as MapReduce also here. So totally three: MapReduce, Hive, Pig, and here Spark core, Spark SQL, and Spark streaming. Spark streaming. This is the team. This is the team of Spark, and this is the team of MapReduce. So which team you want to use for your processing? That we have to decide. Okay. So there are many advantages when going with Spark. The main advantage is storage. Sorry, fastness. The main advantage is fastness. It is very fast than MapReduce. How much faster than MapReduce? The Spark, it has proven, the benchmark is given that it is minimum 10 times faster than MapReduce, and it can go up to 100 times. The Spark is minimum 10 times and maximum 100 times can be faster than MapReduce program. Okay, that's up to the team, that is up to the developers, that's up to the industry or company, whether we want to go with MapReduce or Spark. That's up to their wish. Okay, and what we can do with MapReduce? We can process structured data, semi-structured, as well as unstructured data. Okay, but by using Spark also we can process structured, semi-structured, as well as unstructured. Both are possible. Okay, so there are many advantages. So whatever MapReduce is doing, everything can be done by the Spark. whatever MapReduce can do, that everything can be done by the Spark. And moreover, Spark is very fast. That is the reason why the industry is running behind this Spark instead of this MapReduce. But most of the people, that under what situations we will have the conflict between MapReduce and Spark is, okay, under these scenarios we will have a conflict between MapReduce and Spark. Okay, when if we want to go with batch data processing, okay, MapReduce is good and Spark is also good, they can do both. And when you go with stream processing, it is not preferred, the Spark is preferred. Okay, MapReduce stream processing and Spark is used for stream processing. This is not preferred. MapReduce is not preferred for stream processing, it is preferred only for batch data processing. So as Spark can do both batch data processing effectively and stream data processing. Yes, so we will have the conflict here. In the first case we will have the conflict. What is that? MapReduce is good at batch, even Spark is good at batch. Okay, batch data processing. But which one you vote for, that depends. If you want to go with MapReduce, you must be good at Java programming. You have to do the programming in MapReduce. And if you want to go with Spark, and you have to be good at either Scala, you need not be good at Java. Okay, why? Because Scala, for implementing Scala applications, the developers have given APIs for different languages, Scala, Python, Java, and R language. So 4 languages have the APIs for developing Spark applications. But for MapReduce applications, Java, we can write the code in C++ also. No issues. We can write in C++ also. But the thing is, the coding will be somewhat typical. So we feel some difficulty in coding MapReduce, but it's very easy in coding with Spark. Okay. So when you see all these things, all these features, when you compare all these features of MapReduce and Spark, I vote for this Spark only. I don't go for MapReduce. But the thing is, we should have the idea of MapReduce, how MapReduce works. We should have the idea. Then only we can understand the greatness or the advantages of the Spark. Okay, is it clear now? I think the session is clear. Whatever we have discussed, it must be clear to you now. If any doubts, just let me know the doubts. Yes, sir. From anyone, any doubts?
Yeah, Karan, this is Sunil.
Yeah.
See, you said like we need to first initially get the data into HDFS and then do some for analytical, like use some this Hive or Pig or Spark, any other tool for processing.
Yes.
So what does it mean here? It's processing, like it is a data modeling, or it is just generating a report, or like what does it mean by the processing here?
Okay, processing in the sense generating the reports only. Analysis. I told you by using MapReduce and this one. Let me show you this. This one here only. Can you see this here? Yeah, I told you that we can do analysis. Analysis in the sense we can generate reports. Okay, reports. So to this Hive or Pig or Spark, what we can do is we can integrate some reporting tools. We have Tableau and Talent, right? At these reporting tools, we can integrate these reporting tools and we can generate the reports. Okay, the actual processing will be, and what we do is actually by using MapReduce or things, we write some application. We create one application. There's nothing but writing a program. Writing a set of programs, a single program or multiple programs, and we create one application. That application will process, and for generating the reports, these directly do not generate the reports. For this, we need to integrate with this components with this the reporting tools. What are the reporting that we use? Some Tableau or Talent are there. So we can use those reporting tools and integrate with them, and we can have generate the reports there. Okay, that is the main. Generating the report.
The data.
Yeah.
Yeah. So the data modeling will be done in these areas, like because you are getting the raw data into HDFS, right? So
Yes.
from different sources you are getting, but that raw data tables I don't need for my reporting, right? So I need to do some modeling there.
Yes,
So
yes,
data modeling.
yes, yes. That's
So that will.
map. That's what I'm telling you. If the data coming is unstructured, we have to make it as structured, right? We have to pre-process.
Okay.
That is called pre-processing. That pre-processing we can do. After that, we can do analysis.
So that, yeah, so that pre-processing will be done in these processing tools. Is
Yes,
that what
yes.
you're trying to say?
Hive cannot do pre-processing of unstructured data. MapReduce program and Spark program can do pre-processing very effectively. Okay, we have to write the programs for it.
Okay, so this dimension fact tables like that concept will be done in that MapReduce or Spark,
Yes,
correct?
yes, yes, yes.
Okay.
Any questions?
Uh,
Any other questions?
can I add here something like Sunil, like because
Yeah.
when this is the Spark how you used to retrieve the data from SDFS, which is raw data,
Okay.
and then you form your dimension model to feed.
Hmm.
Okay, so the Spark will be feed. It will retrieve the data from SDFS and then feed into your dimension model, where your reporting tool can access directly the aggregated models and show into the report.
Yes, yes,
How kata?
yes. That's the thing. Okay.
Okay.
One question, Karnaka,
Yeah.
this one.
Yeah.
Uh, I was confused a little bit on the Cassandra and Hbase, because
Yeah.
one time you mentioned that these are the data storage, the NoSQL database, and again you one time you mentioned that the real-time data transaction processing component. So just a little
Yeah.
confused here.
Password bolo.
Ask it. Please go on. Please go on.
Are you able to hear me?
Yeah, yeah. The thing is, see here. If we talk about MySQL, let us say MySQL. What we can do with MySQL? What we can do with MySQL? Can we store the data in MySQL databases servers?
Correct.
Yes.
Correct. We can store the data into the MySQL structure form.
Yes, structure form. Can we process them? Process in the sense, loading of data, creation of tables, and I retrieving the data, DML commands and DDL commands.
INC.
Okay, this processing we can do. This call is processing there. The same thing, HBase in HBase also we can store the data. We can clean the data. We can store the data, and we can also retrieve the data based on our queries. Okay. Now the thing is here, what is the backend? What is the backend for storage of this MySQL data? Where the data gets stored actually in the servers, in the MySQL servers. Okay. Now, what is the file system? In which file system this data gets stored? MySQL data.
Based on the operating system.
Okay, operating system, right? Obviously in the operating systems. Okay. HBase. Remember, HBase will use backend as the HDFS. Remember. Hbase uses for storage purpose. For storage purpose, it uses HDFS. But according to Hbase, the data is stored in what? Columnar format. Storage is, when we use MySQL, it represents the data to us in the form of a table, but it doesn't store the data on the, by the operating system. The data is stored not in the form of tables inside the system. Okay, it is stored in the form of some files only, right? Okay, so if it is Windows or any operating system, the data is stored in the form of some files only, but the representation is stored in the form of tables. Similarly, Hbase also uses a file system. What is that file system Hbase uses to store its data? It uses HDFS. Okay, and but the representation of data to us is in the form of tables. Okay, you got my question here. I think you got my point here. Okay. So HBase in the sense
Okay.
backend is HDFS only, but the processing is done by using the queries, HBase language. Okay. Yeah. Any other questions? The question, whatever you asked just now, let me be more clear. I think you have still some confusion with that. Let me clear that. Okay, let me show you this. Suppose if
Yeah,
SQL,
some disturbance is coming. Whoever not speaking, can you keep on the mute, please? Some disturbance is coming now.
yeah. Please,
Go
somebody
ahead.
who is
Yeah,
not
thank you.
speaking, just please make yourself unmute, okay? Okay. So let us say if it is MySQL, let us say this is the machine we are using MySQL. So when we create some table and when we load the data into table, in the backend the data is stored in some file system. Okay, so in some file system the data is getting stored. Here the data will be, so in any file system the data is stored in the form of files only. Okay, if it is a file system the data must be stored in the form of files only, isn't it? Okay, but when we give some query to MySQL, when we give some query, how the data is represented to us, the data is represented in the form of a tabular form. In tabular form the data is represented to us. This doesn't mean that the data is stored in tabular format. It is stored in the backend in a file system in the form of files. But it is something is running. When we give some query, some processing is running in the backend, and that process is retrieving the data in tabular form and is representing to us in a tabular form. Similarly, when we go with Hbase, when we go with Hbase, okay, and the data of Hbase, here also we can create tables, we can store that, we can create databases, we can create tables, everything whatever we can do in MySQL or Oracle or some other RDBMS. And what is the backend where the data will be actually stored? The data is actually stored in a file system called as HDFS here. Okay, normal file system cannot be used for maintaining the data of HBS. The file system must be a distributed file system. So HDFS is a distributed file system. So it is highly compatible. HBase for the storage of HBase data, HDFS is highly compatible. So the data gets stored in HDFS. But when we run query, when we run query, though internally processing, no, something has to run in the backend. Okay, whatever I told you, explain the concept, the data is stored in columnar format and the data will be accessed in random manner. Okay, that is the background process that will run in the background. Okay, that will run. And in this case, whatever I told you, that the data is stored in sequential format. When we submit some query, the data is accessed in sequential form, in a sequential order. If the data is accessed in random order, random access is sequential access. That runs in the background. Okay, that is the concept of HBase, and this is the concept of MySQL background program. Okay, and this is the concept of Hbase background program. This is the storage of MySQL, this is the storage of Hbase. When we give some query, here also the data is stored, the data is represented in the form of tables only, in tables only. Here also we can run, and here also we can run. So whatever the file system we use here the amount of data that we use for storage of data, it is limited. Why? Because they are not distributed file systems. Even though there are some file systems are there, like things like some SCAN or some Teradata, some storage components are there, but the amount of data they store is limited. It is not highly, it is not horizontally scalable. There is some limit on the storage of data. But when we go to HDFS, there is no limit on the storage of data. There is no limit. Why? Because it is highly scalable. It is distributed as well as highly scalable. We can have any amount of data in HDFS. So obviously, when we go with MySQL, the data is getting stored in sequential form. As the data size increases, obviously, what are the background process that is running to access the data? That process will take some time. Why? Because the data is getting accessed in a sequential manner. But in this case, the data will be accessed in a random fashion. Whatever may the size, the time will be constant. That is the advantage we have with this Hbase. Okay, so that's why I'm telling you, it is used
Okay,
for
got you.
real-time transactions.
Okay.
Okay, let
But
us
Spark cannot be used for this one, right? I mean, only Hbase can be used for
yeah.
real-time
Yes,
transactions.
yes,
Spark
it's
cannot be
basically
used.
yes, yes, that is the thing. Okay,
Okay. Yeah.
any other questions? If any questions, otherwise, if you have, what are the processing components used in Hbase Cassandra? Is Cassandra used for storage or processing the data? Yeah. See here, Cassandra is used for storage and processing the data. That's why I'm telling you here. Let me tell you. Now, think here it is. Just now I told you that HDFS, sorry, HBase. HBase, its backend for data storage will be HDFS. HDFS. Okay, this HBase and HDFS. Coming to Cassandra. Coming to Cassandra. Now, what is the architecture followed by HDFS? Master slave architecture. Master slave architecture. Already we have discussed yesterday about this architecture. Master slave architecture. And what is the architecture followed by HBase? The same architecture. Again, master slave architecture. It is compatible with HDFS architecture. It is compatible. Okay. And coming to Cassandra, it is not master slave architecture. It is peer-to-peer architecture. It is peer-to-peer architecture. It is not master slave. It is peer-to-peer architecture. Okay. And the file system, its file system is different. It is called as CFS. It will have its own file system that is called as CFS. We have to install Cassandra. It is also distributed. It is also distributed file system. CFS stands for Cassandra file system. Cassandra uses its own file system called as CFS, Cassandra file system. It is also distributed file system. HDFS master slave, Hbase master slave architecture. CFS is distributed file system, and the architecture you internally use is peer-to-peer architecture. Okay, this is different. Hbase and different, but both can be used for the same purpose. Hbase can be used for real-time transaction purpose. Cassandra also can be used for real-time transaction purpose. And one more thing is, both are columnar-oriented databases. Both are columnar. Whatever the way in which data is stored in Hbase, the same logic is being used for storage of data by using Cassandra also. But the file systems are different here. The architectures are different. Okay, it is used for storage as well as for processing also. Okay, is it okay, Malesh?
Yeah, that's clear. Yeah, thanks, sir.
Right.
That makes clear.
Right. Any other questions in the chat? No questions. I find no questions here. Okay, I think we shall wind up the session for today. So you can have a discussion among yourselves and give me some confirmation at least by tomorrow. Okay, by the end of the day or by tomorrow, we can give me some confirmation so that we can start the session from Monday onwards. Okay, thank you.
Yeah. Sunil, any WhatsApp group is created on this one? Anyone from the call?
Yeah, I
Sunil,
think WhatsApp group is created. Created by, I think, Chakrapani has created the group. Chakrapani and Vivek, they are the group admins. They can you can
Yeah,
contact them.
might be Vivek might be knowing Malesh. I don't know about, because Vivek only pings me about the details.
Yeah. Vivek and I think Chakrapani is also as admin. You can contact them. Okay. You can just get your number added to that WhatsApp group so that whatever the updates are there, I will update them. Okay.
Okay.
yeah.
Okay.
That
Thank
would be
you.
great.
Thanks a
Okay.
lot.
Yeah.
Thank you.